Here, me and Gerardo are going to talk about EGFxSet. First, I want to talk a little bit about our background. Sorry about that. I have I don't know how it went backwards. So here we go. I'm Hegel Pedroza. I'm a postgraduate student in the National University of Mexico. My background is mainly as a composer and electric guitarist, interested in technology as a medium for sound installation and multimedia composition. I've been a performer and a composer for over a decade.
Hi, everyone. Can you hear me? All right. So my name is Gerardo Meza. I'm a composer and sound artist. Same as Hegel, I'm currently enrolled in the Music Technology Master's Program in the UNAM in Mexico City. Previously, I studied music composition at the Rosas Conservatory and music technology in the NES Morelia, where I focus on algorithmic music and music creation with interactive systems. So the project we are going to talk about today was born during this year's spring semester in the seminar Deep Learning for Music Information Retrieval, Generative Models, which was taught by Iran Roman as an optative subject in our master's program. So without further ado, today we're presenting EGFxSet, an electric guitar effect dataset that features recording of all clean notes possible in a Stratocaster guitar. So we recorded the 5 pickup configurations available in the instrument and augmented this data using 12 real guitar effects. As we all know, it is virtually impossible to create a data set that represents all possible electric guitar timbres in real music. So existing guitar dataset had made compromises to balance musicality, timbre diversity, effect realism, and size. One common approach of this dataset has been to simulate effects with software and randomize the effect settings. Ours, in contrast, was recorded using real hardware, making it more relevant for MIR tasks on real music. In addition to this, we created annotations for the effects parameter settings and let our data free to download via Zenodo and through Mir Data Loader. So we use a 22-fret Stratocaster guitar, model 2004, with the standard tuning to record this dataset. It had strings with a gauge going from 0.09 to 0.42 millimeters, and it was plugged with a 2 millimeters thick plastic pick. The pickups used were Fender single coils in a standard 5-way configuration, which are bridge, bridge middle, middle, middle neck, and neck. All 5 pickups were recorded using tone and volume notes at max position. So to record the dataset, a professional guitarist, which is Hegel, play each note available in the guitar, resulting in 138 notes played. So this process was repeated for all the 5 possible guitar pickup configurations mentioned before, resulting in a total of 619 clean notes. During the recording process, the guitarist wore headphones to listen at 60 BPM metronome and played a note every 8 seconds. Using the recorded clean tones, we prepared a DAW track where all notes were played one after the other. The computer's audio was sent through the output of an audio interface, which at the same time was connected to the input of each audio effect. Finally, the output of these effects were connected to the input of the audio interface, creating a round loop.
Well, this setup allows us to play the track with all clean tones and record them while they went through all the different effects. We use an Audi ID14 audio interface and a MacBook Pro 2013 laptop using Logic Pro X, and all the audios were from 22 kilohertz and 24-bit depth. Well, each file had specific annotations. Those are the audio path, that is the specific folder or location of the audio file, an ID attached to each audio file, a string fret tuple, that is a pair of numbers. The first one, the number of the string, and the second one, the number of the fret. 0 when the string was open string without any fret, and then 1 to 22 accordingly to each fret. Also, we have the note, that is the note name in a musical convention like C4, D5, and so on. Also, we have like the MIDI note, that is the MIDI number of each note, and the pickup configuration. Here is like bridge, bridge middle, middle, middle neck, and neck. Also, we have the effect, that is the name of the effects used. We use 12 different effects. I'm going to talk about them later on. Also, the model, that is the commercial name and version of each hardware. Like this one is the Ibanez Tube Screamer Mini, Boss PD2 Blues Driver, Rocco Rats 2 Distortion, Line 60 L4, Orange CR60 Combo Amplifier, and so on. Also, we use an effect type. That's a categorical name of the effect type, abstracting away the effect's specific name and brand. We also have the knob names, that is the parameters names given by the original manufacturer. The knob type, those are language descriptors from a categorization we use, and the setting of each pedal, that is the position of each knob and each switch, going from values from 0 to 1. Our functional categorization explains how all the effect parameters in our dataset change the guitar's clean sound. We group them using the following descriptors. Volume dials, those are the ones that adjust the amplitude. The selector switches, selectors of discrete parameters of each effect. EQ dials, controls of the spectral equalization. Effect amount dials, that is how much the effect is affecting a dry signal. Effect decay dials also, and rate dials. The rate dials were adjusted manually to match 120 BPM. That is like a standard time whenever you use a dial. And we matched them. Like, you know, this phaser only have one dial, that is the rate one. We match the dial with a metronome to 120 BPMs. Here are all the effects used and each parameter of each effect. You can see this information in our website. Maybe we have time to check it out. I'm gonna change how I share my screen with you, so you can see it. Here it is. So we have all this information in our website, EGFxSet.github.io, and the effects are right here. It's like an interactive table. You can hear a little example of each effect. All audio files were normalized and have like a fade out of 2 seconds. Going back to the presentation. I'm just gonna try to do like a brief summary of the dataset. We have 8,970 second-length audio files of each note of the guitar processed through the 12 different effects. Those are 690 audio files per effect and 690 clean tones that sum up to those 8,970 files. With this, we hope EGFxSet will help to develop research in areas such as automatic guitar transcription, guitar denoising, guitar sound isolation, effect synthesis, effect transfer, and many more. So thanks you all for your time. Please check out our website if you have any more doubt. Don't hesitate to write us or contact us in any way.
Thank you. That was very nice, and the timing was perfect. I must highlight that. So I'll just say that we have 3 minutes for questions, and the whole point here is that we talk. Doesn't have to be exactly about the presentation. It could be about future work or anything you feel like asking them about. It could also be about their program of studies. So we have like 2 minutes and a half for questions of any kind. Martha, go ahead.
I just want to ask, I know that you guys are presenting this in the Izmir demo. What is the demo going to be like? You thought about that already? Is the first time that you are involved in an Izmir venue thing? Okay, that's nice. It's a very nice place. So don't be afraid. People are super welcoming, but like just curious what your ideas are on that.
Well, thanks. We're doing that remotely, and we sent a video like 4 minutes. We try to cover all this, and I don't know. I mean, the schedule, it's very different from Mexico hours. I will try to attend. I'm not expecting anything, right? So I'm just happy they accept this paper.
What time do you have to present, supposedly?
6 a.m.
Okay. Yeah. No. I think you do a great job with the website, with the interactive part. So that will also help.
Thanks.